What's up, guys? It's Jamar here. So I've added procedural generation for pixel drawing. I'm really excited for this one. So I tried it a plethora of ways. Well, really just three ways. First, I tried to use the current implementation of layers to uh, try to just brute force it. I tried to create a separate layer class. Let me just go here. Uh, So I tried to create a separate layer class and increase the max objects to 100,000 for pixels. That didn't really work simply because I didn't want to break this pipeline of how things are being rendered. So that option was kind of gone before it even started. Then I tried instancing, um, but the problem with that was I couldn't really. There's kind of here. Let me just go to the shader here really quick. So there's kind of a max limit for how many elements you can have. So here's my instancing shader here. Um, but there's kind of like a max size, so I could do 400,000, which would be the number of pixels, and then instance it using like just quads. So that didn't really work either. Um, so I could use instance vertex arrays, but then I would have to do it through the shader. I didn't really want to do that. I wanted to do this through the CPU for controlling each pixel. So then I had a third option. I remember seeing something about GLText sub-image 2D when I was debugging textures a few weeks ago, and I wondered. I was like, well, what is that really used for? Because I didn't really see a use for it besides like tile maps or like tile-based textures, like RPG 2D type of games where they have like the square-based textures. Um, but then I thought about it. I'm like, well, wait, I could probably use that and just render it to a quad and actually just have all the textures be handled by OpenGL to spread across the quad, right? And then I could just use that. And if I just get the quads small enough through batch rendering, or not even through batch rendering, but it's only one quad. But if I get the quads, essentially the quads, they're quads, they're texels, right? They're really pixels, but they're called texels when used with the like texture units for textures. Now I made this pixel buffer of 400,000 values, 100,000 pixels, so that could be really dense. And so the width is 500 across the screen and the height is 200. I just think that looks really nice. Um, and so basically, these pixels, and make sure pixels and texels pretty much is used. And so layer manager, we have this layer set up. Here we create the quad, we give it a type shape type of buffer. And so basically we're looping through all 400,000 values and setting it to zero so it can be transparent. And then we're setting our pointer to our state as well as to this pixels layer. And so here we're drawing a pixel. So first we get the actual coordinate of x and y. I was testing this earlier, so I had it converted because I was converting it from the screen width and height to scale it to what it was in the actual texel space. This didn't really work because it was skipping values. So it was kind of having like little lines in between, but it was like dashed. So when I set these back to its original value and just had it go through the actual buffer width instead of going through the actual screen width, then it worked properly. So this is what we get right there. So we can draw a line. We can draw individual points. So I'm just looping through to draw a line from end to end. And so something I can do here really quickly. Yeah, I added some more colors. I just used the color picker here and just divided it by 256 to get the different colors. I used those colors in the example because like for the max grid area algorithm video I put up just a while ago, but then I forgot to move them back into the original code where my actual Git repository on my local machine is so I can push it. That's kind of why those were lost. I just had to flip these around the other way. So yeah, because J modules want to always be equal to zero. I'm a little bit in a rush. So, anyways, J modules 5, so that just means it's divisible by 5. We display red, so on and so forth. So if we run this, you can see we get some beautiful colors on the screen. Let me just make that bigger and move my mouse out the way. Hold on 1 second. All right, I had to get my screenshot for later on for this video. So there we go. All right. Um, okay, so I mean that's pretty much it. I didn't really explain like kind of the details about it. Basically, all I did was I just set up this layer here. I kind of sorted through it um, and put it before the fixed layers and after the non-fixed layers, so you can still render your frame rate here. So we can just go here when we do this, and we can render. You see, we get our frame rate information. You can see pixel by pixel drawing of this being submitted every frame. We're still getting about 80 frames per second, which I mean is still over 60 frames per second, which I think is pretty sweet. Um, so if we just get rid of that, actually, the reason why that's so low of a frame rate is because when we actually come here, we're drawing this each frame. Um, we're drawing it each frame. Basically, every time a pixel is drawn, we set this to true. So if they're not drawing anything, if the user isn't drawing anything, then we don't set it to true and we don't draw. We don't submit. Now, it's up to the user to implement state management so that they can actually draw when they want to. Now, if they're doing animations or something that's constantly drawing, well, then it'll still be over 60 frames per second as I just shown you. But you could also cache the previous draw call or the drawn pixels inside of this function here, which I might wind up doing so that those don't get drawn again. That's another way we can speed it up. But or we can do this every few frames. We don't have to actually draw this every single frame. So basically, just, okay. So basically, we render it right here inside of texture set, which if you remember, we call each frame pretty much when we render a layer. So basically, when we draw this, only if the asset grouping is 0, I basically taken up slot 2 of pixels. So slot 1 is solid color of quads and primitives. Slot 2 is obviously the text for bitmap font rendering, and slot 3 now is this procedural generation pixel drawing. And then these other two are just things I've added for testing. So basically, if it's slot 2, and obviously its asset grouping is 0, so we make sure it's slot 2, and then we basically update. And so you can see here the width is 500, height is 200, 100,000 pixels. I felt that was pretty dense. And as you can see in the image I just showed you earlier, that was a pretty um, decent, I don't know if that's the right word, but granularity. Uh, Granularity. I think it was pretty decent of a grain. It was really distinct and it was really kind of blended well together. So that's pretty much it. That's kind of what I implemented. You can see it wasn't too much, many lines of code for an addition. It's way better than brute forcing all those quads onto the screen, which would have been distinct as well and more indices and everything. That would have been a mess. So I'm glad I'm doing it this way. The frame rate didn't suffer too badly. Like I said, there's ways to optimize it, but that's pretty much all I wanted to show with you today. Next, I'm gonna be working on the GUI framework to pretty much like do things like a file bar for like file, edit, stuff like that. Some simple GUI components that are pretty common, like a vertical list scroll, the nav bar, buttons, um, maybe even like a text input and everything. I still haven't implemented user input, as well as mouse events. I haven't implemented either one of those yet because I simply haven't gotten around to it. So basically, now that this is implemented, I can implement user input next and then the GUI framework stuff. So that's kind of what I want to do. I hope you enjoyed it. If you have any questions, please don't hesitate to leave it in the comment section. And wait for it. Wait for it. Until next time.